So this is the first problem of today's TIF 2. And in this problem, we are given that we have two positive integers, x and y, and we need to repeat the following operations until x is not 0. So if x is more than y, then we need to swap x and y. Otherwise, if x is less than or equal to y, we need to set x as y minus x, that is the difference. Y was more, right? So difference between these two, and y is equals to x. So finally, we need to print y. So now if you follow this, if you try to follow this, if you try to find a pattern, maybe you'll find it, or maybe it will take time for you to find what is really going to happen. But this actually is if x, like if x is less than y, then swap x and y. Otherwise, x becomes and y is x. So this is Euclidean theorem, the basics of Euclidean theorem. And finally, there is also one more conditions. If one thing, like if x is 0, then you can just return y. So this basically is I think I have written this. Yes. So this is your Euclidean theorem. And can someone tell me what does this give? This gives you GCD of two numbers. Here, GCD of x and y. So this is a very well-known theorem that is used to find GCD. So in this, you are required to find what is y when x becomes 0. So you can simply say that this is nothing but your GCD. And by the way, if you don't know this, you can apply brute force also. That will also work. You can just do these operations, do these recursively, or do them while you can do something like this while while x is more than more than 0, you can do these operations. That will also work. But if you know, this is actually Euclidean theorem, and you can just find GCD and print it. Is it clear? Yes, no? Okay, doing with while loop will give you TLE. Okay, there are test cases also. Yes, yes, yes. And the values are also updated 10 to the power 9. So let me show you the implementation. So this is the implementation. Just take x and y as input, and then just print the GCD of x and y. Is it clear? So let's go to the next problem. So the next problem is, we are given a permutation P of length n, and for each I between 1 to n, we need to find the number of subarrays of P with some I. And okay, this is okay. So what we are given that there's a permutation P of length n, which has numbers between 1 to n. Okay, and you need to find for I between 1 to n, you need to find the number of subarrays with sum equals to I, right? This is what you need to find. So first of all, can someone tell me what is the sum of this permutation, like the complete sum of this permutation? What is the sum? So this is nothing but, if you write it down, it at there will be all of these numbers, right, up till n. So this is a arithmetic progression, and the sum of this is n into n plus 1 by 2. So can you tell me what is the smallest sum possible of any subarray of this permutation of length L? I don't know whether what are the elements. Let's say L is the length of the subarray. I don't know what elements will be in this, but can you just give me a lower bound? Minimum sum. L is like, give me in terms of L, not constant. Like if someone is saying one, why one? If you are saying n, like how are these coming? Like I didn't say that you have at max like there will be one element. Yes, it will be L into L plus 1 by 2. Minimum, this will be the sum. It can be more than this also. Let's say the numbers in your length were like in this array were 3, 5, and L is 3, and these are the elements. So definitely some of these, n is let's say 100. So some of this is more than 3 into 3 plus 1 by 2. But you won't get less than 3 into 3 plus 1 by 2 for any subarray of this permutation of size 3. Why? Because the minimum sum that you'll get is of this subarray, if these three elements are indeed together. So one thing is clear that this is the sum. So by the way, now looking at this, if L length subarray has sum as L into L plus 1 by 2, then this tells me that, see, I have to find for I from 1 to n, I have to find how many subarrays are there, how many subarrays, number of subarrays with sum I, right? Sum as I. So my maximum sum that I have to find is n. So maximum, this thing should be less than equals to n. So from here we get a estimate, a rough upper bound for L as L should be less than 2 times n square root, right? So your length of subarray should be less than or equal to this. So what you can do, you can just like for every I, you can start your subarray there and go up till at max this much length and find sum of all of these. And you can create an answer vector, and in that for this sum just do plus plus. Finally you can print this answer vector. And what is the time complexity? Time complexity is nothing but n times root n. Is it clear? Yes, no. Okay, so let me show you the implementation. So this is the implementation. In this, I have first taken permutation p as input. Then this is my answer vector. So I'm starting from 0 and I'm going till n. Now I haven't explicit like my j is starting from I, but I'm not going up till like I plus under root of twice n, but I'm going up till n only. I'm checking like this. So initially my sum is 0. I'll add this element. While my sum is less than equals to n, I'll keep doing this answer of s plus plus. Why? Because see, once this becomes 0, I definitely know, like not 0, it becomes more than n. I know that this will become more than n once my length is more than under root of twice n. So that's why I'll break my loop here. You can, instead of breaking, like instead of doing like this, you can include it here also, but then you'll have to check this, like you indeed, like you cannot skip this check, because it's possible that in that, like in that length also you'll get some more than, because it's just a lower bound, right? But it's not like in that length you can get a sum more than n. So don't like just blindly do this, otherwise either you'll have to like, you cannot have a size like n here, but if you do that and you have a size n, you might get runtime error. So you need to have this check, and if you don't want this, you can include the constraint here. So finally, once this loop gets terminated, we can print our answer. Like for each I, how many subarrays are there which have the sum as I. Is it clear? Okay, so let's go to the next problem. So the next problem is this, and in this problem we are given that there is an array A of length 2n consisting of exactly two occurrences of each integer from 1 to n, and we need to find a permutation p of length n such that for each I between 1 to n, if we delete both occurrences of pj for all j between 1 to n and a without changing the order, from a without changing the order of remaining elements, then at most a by 2 elements are between both occurrences of pa. So let me explain this. Let's take an example. So the first we're given 1, 2, 2, 1. So what you have to do, like what element will you, like if you have 2, 1, then all the, if if you have this element, then all the elements after that, like in your permutation, let's say this first one is the array A and this is your permutation. So in your permutation P, all the elements that occur after this point, which all elements occur after this point? Like for the after the first position, this thing, right? So you'll delete both of these elements. And what is the number of elements between two? It's like your modified array will be 2, 2. So how many elements are between 2, 2? It's 0. So this thing holds, like there are at max these many elements, size of A by 2. Now, if you have, once you come to this point, second point, so you need to delete only first element. So if you delete, no, if you come to this point, you cannot delete anything, like you won't delete anything. So you have 1, 2, 2, 1, right? Yes, no. This is what you'll get, right? Okay. So now, how many elements are between 1? There are 2 elements. There are 2 elements. And what is size of A by 2? It's also 2. So that's why this is a valid answer. Now let's take this example. 1, 1, 2, 2, 3, 3. So in this, one of the valid answer is 3, 1, 2. Is 1, 2 also valid in this? Okay, is 1, 2 valid, also valid? What do you think? For 1, yes, it's valid. See, for 1, you'll delete 2, 2. There are 0 elements in between. For 2, you'll delete nothing and there are 0. Yes, 1, 2 is also valid answer. For this, there is this answer 3, 1, 2. So 3, 1, 2, how 3, 1, 2? For 3, you'll delete 1 and 2. So 1 and 2, all of these are deleted with 3, 3. 0 elements are between. For 1, you'll delete just 2. So 1, 1 and 3, 3. There are 0 elements in between. For 3, for 2, you'll delete nothing, but there are 0 elements in between. Another valid answer for this is 1, 2, 3, right? Or 3, 1, 2, like whatever. So how to find this thing? So like this is a very simple problem, just an observation that if there is an x here, there is somewhere an x here. If there is a y here, there is a somewhere there's a y here. If there is a z here, there's somewhere a z here. So see, this is what you'll print. So this is the first element. This just tells you that whatever after this is will be deleted when you're considering this thing, this pair. When you're considering this, everything here will be deleted, not this thing. So what you can do, if this thing and how many elements should be in between, at max a by 2, right? So what you can do, there's an easy way to do this, that if x comes first, you just consider it. Why? Because you know for sure that there is no element which is at the left of this, which will be left, right? So and the other x will at max, like if this x is bit here and it's coming between z and z. So when you are at this z, like z is here, so when you're considering this Z, this occurrence won't be removed. Like it will still be there, but A by 2 elements are allowed, right? A by 2 elements are allowed. So even though this X will be left in between in array A, like only one of these will be in between Z. Like try to understand my point. See, there can be at max half of the elements in between when you're considering 2 points. So if you consider the elements which occur first, like whichever is occurring first, if X is here, Y is here, Z is here, so first X, then Y, then Z, then let's say alpha is here. So you should consider X, Y, Z, then alpha. So this should be your answer. Why? Because see, once you consider X here, you definitely know that at least one of its occurrence is not between anything, between any two values. Why? Because it is the first value. And another value, even though if it's in between, since one value is outside, this thing is like this thing won't get invalidated. Why? Because there can be half of the elements in between. One is not in between, one is in between. Same thing for the Y. Why? So Y is one here and one here. So you know that once you are done for X, like you have already considered X, right? So this Y, this is the first occurrence of this. So whatever is the second occurrence, even though it's occurring between some elements, one occurrence won't be in between. So again, one will be outside, one will be inside at max. This can be also outside if let's say I had Z here. So that's why just start your iteration from left side, and as you are getting these elements for the first time, include them in your final permutation. That is your answer. Is it clear? Because by the same rule that one will be inside and one will be outside. So this is a like an observation problem. You don't require any kind of knowledge. Like there is no algorithm behind this. This is just constructive plus observation, ad hoc problem. So, okay, you didn't understand the problem statement. So, like at first, I also like misunderstood this. Like I misread this. But what helps is try to look at the test cases. I like when I first read the problem statement, I was also confused. Like, what is it asking me to do? Like this was not clear to me. But then I read this test. Like these two test cases are also like they don't convey any meaning, but this thing, if you go through this like one by one, and also this thing is also okay, like this part. So if you go through these, if you would have gone through these and try to like not just read these, try to solve them, like try to like using a pen and paper, try to see what's happening. Then you'll understand the problem statement. And once you understood this problem statement, then it's really easy. So let me show you the implementation. So this is the implementation. This position is nothing but like which all elements I have visited till now. So, and this is my final answer. So what is that I'm doing? I'm going through all the 2n elements. I'm taking them in input. This is my array A. Then I'm checking if this element is not marked. I'm marked like eventually I'll mark every element, but if the element is not marked, that is I'm visiting it for the first time, then I'm including it my answer. Finally, I can print my answer. So hopefully this is clear, right? Okay, so let's go to the next problem. So the next problem is this. In this, we are given that suppose you have an array B consisting of m non-negative integers, then B is called good if we can make all the elements of B equals to 0 by performing the following operation. Starters, select two indices I and j, then take OR of these two and store them in X. So X is OR of BI and BJ. Choose any two indices and do this. Then replace BI with this OR result minus BI and BJ with this OR result minus BJ. So we are given integers n and k, and we need to count the number of array A such that A is good and every element of A is between 0 and 2 to the power k. So first of all, let me explain the problem statement. K can be anything. You don't actually have to create the array, right? You just have to, so, like, there is a doubt if like 2 to the power k, and k is up till 10 to the power 6. So this number is like infinite. Like you cannot store this number 2 to the power 10 to the power 6. But they are not asking you to find the numbers actually, right? They are not asking you to create the array A. They are just asking you how many good array A's there are such that this thing is true. So let me explain this first of all. So if you are given an array A is good if you can have every element, you can convert every element to 0 by doing this. Select I and J, then do like find the OR result of these, and then Bi becomes X minus Bi and Bj becomes X minus Bj. So let's try to see what is actually happening. See, once you created OR of these, if let's say there are 4 cases, the bit was set in both of these, the bit was unset in both of these, the bit was set in one of these, the bit was set in one of these. So if the bit was set in on both of these, this is my Bi, this is my Bj. What will be my X? My X will be, it will be set in this, it will be unset, set. What will be my final Bi dash, Bj dash? So it will be unset in both of these, unset. If it is set in X and set in Bi, it will be unset because we are subtracting, right? And Bj will be X minus Bj. So now it will be set here, the same way here. Is anyone having any doubt in this? Like these are simple conversions. I have found X using Bi or Bj, and then I have just found Bi dash using these two formulas, Bi dash and Bj dash. Is it clear? Yes, no. Okay, so now if you look at this, if there's one bit set, if you're performing this thing, it will simply go from one element to another element. We can only make bits 0 if we have a pair. Eventually we have some elements, like some element will have some bits, some element will have some bits. We can perform in any number of operations, but the thing is, if we look at individually at every bit, it should occur even number of times. If it occurs odd number of times, it won't go anywhere. Like it will be finally in some element. So every bit, like in all the numbers, like let's say this is the first number, this is the second number, third number. So in all of these numbers, let's say there are these 4 bits. So each of these 4 bits, for every individual bit, it should occur odd number of times. If I take the count of how many times each bit occurs in these 3 elements, individually every bit should occur odd number, not odd, even number of times. Why even? Because they get cancelled in a pair. Is it clear? Yes, no. Okay. So now, how many bits do you have if the element should be less than 2 to the power k? How many bits do you have? Like here I have written 4 bits. How many bits do you have if the number is less than 2 to the power k? If the number is less than 2 to the power 2, that is 4. How many bits do you have? You have 2 bits. 0th bit and first bit. So if you have 2 to the power k, the number should be less than 2 to the power k. You have k bits. So if you have k bits, and for each, how many options do you have? If you can select any even. See, if you, no. If you do like this, that for if you okay, let's see these are first, second, third, fourth, all the way up till there are n numbers, and you are saying for each you have 2 options that you will select it or not, but then you're considering that case also, which is odd. You might have a selection in which you selected like this bit is set in odd, total odd numbers, like total count of numbers in which this bit is selected. I'm talking about this, let's say this bth bit. This bth bit should be set in even numbers. So either in 0 or in 2 or in 4 numbers. So this is the count of numbers in which this bth bit is set, or in 6 all the way up till n if it is even, otherwise n minus 1. So this is number of ways to do this is NC0, NC2. Number of ways to, like I'm just choosing NC6, all the way up till NCN. So if you add these, this is a very well-known formula. Like, but there are two formulas. The first formula is NC0 plus NC1 plus NC2 all the way up till NCN is always equals to, like this thing is 2 to the power n. And if you only have these elements, NC0 plus NC2 plus NC4 all the way up till NCN, you have this thing is 2 to the power n divided by 2 or 2 to the power n minus 1. These are the two formulas. So this is applicable here, right? We am adding only even. By the way, even this is equals to NC1, NC3 if you take all the odd. But you don't need to, like, you don't need this thing for this problem, but just remember this, that these two are equal. So where was I? I was here. So this is the sum that we need. We know that it is 2 to the power n minus 1. And how all these options are actually going to be multiplied how many times? K times. Why? Because there are k bits. So 2 to the power n minus 1 into 2 to the power n minus 1. How many times? K times. Why? Because there are k bits. Like I said, you need to decide this for all k bits. There are k bits. So the final answer is 2 to the power n minus 1 to the power k. Is it clear? This is your final answer. Okay, it's clear. So let me show you the implementation. So just take n and k as input. Then first your answer is 2 to the power n minus 1, and I have stored this in answer, and this is further. For this, I take power as k. By the way, this is not inbuilt power function. This is my binary exponential. And in this, I have taken modulo. Like binary exponential, everybody knows what binary exponentiation is, right? If a to the power x is what you have to find, and x is even, then you can write this down as a to the power x by 2 into a to the power x by 2. And you just have to find this and then take square of it. Otherwise, if x is odd, this is just fundamental, right? Then do a to the power x by 2, a into a to the power x by 2. So this is binary expansion, and here I have taken care of modulo. So don't forget to take mod into consideration. So this is what I have done, 2 to the power n minus 1 to the whole, like to the power k. Finally, we can print our answer. Is it clear? So let's go to the next problem. So this is the next problem. In this, we are given that there are, like, we are given two integers, n and k, and we need to find a permutation p of length n such that maximum value, like starting for every I, like in the prefix, what is the max? Like you need to find the maximum in the prefix of I, find the minimum in prefix of I. That should be equals to k. Like sum of this for every I should be equals to k. N and k are given to us in the input. So if there exist multiple p's, we can print any, and the answer always exists. Like I'll prove how the answer always exists. First of all, what is that we need to find? We're given n and k. We need to find a permutation p such that for every I from 1 to n, we will find maximum in prefix. Like this is sum for every I from 1 to n, sum of prefix in I minus minimum in prefix of I. Prefix of I, and this should be equals to, finally this should be equals to k. So let's say this is your array. So for this thing, prefix maximum is this element only, prefix minimum is also this element only. For this, the value is 0. For this also, you'll find what is the maximum, what is the minimum, subtract these two, the value will come here. For these, find what is the maximum out of these three elements, find the minimum out of these three elements, the value will come here. Similarly like this, and finally you'll have to add these, and this should be equals to k. So this is the permutation that you have to find. So how to do this? So first of all, what is the minimum value that you can get like this? See, if the permutation is like this, 1, 2, 3, 4, all the way up till n. Finally, see, first of all, see that the first thing in this, like first thing, maximum minus minimum will always be 0. And for the last thing, maximum out of all of this prefix and minimum out of all of this prefix will be always n minus 1. Is anyone having any doubt in this? The first will always be 0, the last will be always n minus 1. Because the maximum in this will always be n, minimum will always be 1. And for the first element, the minimum and maximum is the same element. So now in between, either like if you go towards minimum, this is what you'll get. And if you go towards maximum, then this is what you'll get. All the elements, like this is 1 here, this is n. Then you'll get this kind of a retrieval. And otherwise 1, 2, 3, if you have something like this, then you'll get this. So the above one is in case of minimum. If you want the minimum sum, like I'm talking about this sum, if you want this to be minimum, this is these values. You just have to find the sum of these. And for maximum, this is the values. These are the values all the way up till n minus 1. So in this case, the minimum sum that you can get is, again, this is an arithmetic progression. Instead of n elements, there are n minus 1 elements. So the sum is this. So this is the minimum value. And the maximum value is n minus 1 times n minus 1. So there are n minus 1 elements added n minus 1 times because the first element is 0. So if your k is not between these two limits, the answer is simply minus 1. Right? Yes, no? The answer doesn't exist. If your k is not between these two, otherwise the answer always exists. Now how? First of all, consider this only. 0, like consider this thing that you have this arrangement 1, 2, 3 all the way up till n. So what is the sum that you're getting? 1, 0, 1, 2 all the way up till n minus 1. So okay, let me write this completely. You'll get something like 0, 1, 2, n minus 3, n minus 2, n minus 1. So this is because you have elements like 1, 2, 3 all the way up till n minus 2, n minus 1, and so this is your permutation, and this is your values. That is, values is nothing but prefix maximum minus prefix minimum. So what I can do, just keep shifting this nth element backwards till your sum is less than, or till your sum is less than k. See, if I shift this n here, you can keep this element afterwards. So this will also become n minus 1. If you keep this n here, this will also become n minus 1. So keep doing this till your sum is less than k. And once your sum becomes like, once you cannot move this further, like if you move this further, this will become more than k. In that case, let's say currently my sum is 10 and I want 13. And I have reached my, like the value here is, let's say it's 5 and my n is 10. So if I shift, like the value that I was getting here is 5, and like the position here is 5. If I replace this with n minus 1, that is 9. Like if I bring my n here, so I'll get 9, n minus 1, 9, right? So I got my value, final value increased by 4, but I only want this to be increased by 3. So in that case, you can just keep the element that you need here. So you have a 5, you can keep a 9 here. Why 9? So not 9. You can keep 8 here. You needed, yes, yes. Because if you have 5 here, you're getting the value 4, right? Actually, earlier I said 10. So if you keep 10 here, your value will increase by 5. Like final value, instead of 4, you'll get 9 here. So you instead of 4, you need 7 here. So how will you get 7 here? If you keep the element 8 here. So 8 will come here, n will come here, and after that, all the remaining elements can be placed in any manner. Why? Because whatever order you choose here doesn't matter. The maximum is fixed, the minimum is fixed. The values at like the prefix maximum minus prefix minimum will be n minus 1 only. And your final sum will be equals to k. So you can always create your answer. Is it clear? Yes, no. Okay, so let me show you the implementation. So in this, first I have checked that, like I have taken n and k as input, and I have checked that k should be in between this range only. If it is not, just print -1. If n is 1, then this is also a very simple case, just print 1. Otherwise, we have to create our answer. So how to do this? First of all, for I from 1 to n, just like have these elements only, like bi is equals to I. One, like your elements are 1 to n. Then like this is just subtracting the value, like k, like currently your sum after this point, like either you can first calculate bi, like bi is nothing but what are the values that you'll get in values array. Okay, so either just find the sum of it and later subtract it on with k, or just keep subtracting, like for 1 to n minus 1, just subtract it with k, basically these values. Where is it? Like the minimum values were this thing, right? This thing. So either subtract this thing directly with k or subtract this thing one by one while we are creating, like inserting these values in array B. So while k is more than 0, just keep coming backwards. Like this is like not such a like good way. Like I have done this in a long way, but what I'm doing, I'm keep coming backwards up till a point that I cannot go back further by creating that, like by making the value like by making the number at that position equals to n, because after that point every value will be n minus 1, because the first element is n, and because the first element is 1 and this element is n. So maximum and minimum is decided, so every element will be n minus 1 only. But if I go one more further back, like one position further more back, I make that thing also n, then instead of getting something as x here, I'll get as n minus 1. So this, now the sum is becoming more than k. So that's why I'll come to this point, and whatever is like required here, I'll adjust that element. So that is exactly what I have done here. First, reach that point, adjust the value, and after that point, this is just like in your set, like in my set, I have all the elements, and I'm just like, you can insert in any order, I'm inserting in them in increasing order. So just like include them in increasing order. Finally, we can print our answer. Is it clear? Like the implementation is really easy. I have implemented it like unnecessarily in a long way. Okay, so that's it. And thanks for joining. Bye bye.